Okay, so we are coming up on our last or our second half of geometric sequences. The main application, and this is an applications course, the main application of geometric sequences is with interest. It's used all the time with interest. It is an exponential equation, which means it is a geometric sequence. There are all sorts of other things that fall under the interest umbrella that actually have nothing to do with banks and loans and mortgages and interest rates and credit cards and all of those things. But anything that grows at a certain percentage rate or depreciates at a certain percentage rate, those are all going to fall under this umbrella, and it all goes with geometric sequences. So this is kind of why we learn about sequences, is for this thing right here. There is a formula. There's multiple formulas. You'll see in your textbook that there's one that's for simple interest and one that's for compounding interest, but there's only one formula that's in your formula packet, and it's because technically that formula could apply to either of the situations. So we're only going to focus on that one formula, the formula that's in your packet, and how we interpret it for all the different situations that could pop up in this pretty massive umbrella of applications. Okay, so the formula that you'll see, it's right under geometric sequences. I think it's like page 3 or something like that, is as follows. The formula is FV equals PV times 1 plus R over 100 times K to the Kn. So a pretty crazy formula. There's a lot of different things that are going on here. We're going to go in and we're going to define what they are. FV is your final value. Your final value is how much you have at the end, whether it's how much it's worth at the end of a certain number of years with a certain percentage of depreciation. If you bought a car and its value depreciates over a certain amount of time, the final value would be after 10 years. What is the value? That's what your FV would be. PV is your present value. I actually really don't like that they call it PV. Because really what it is your initial value. So it's the amount that was initially either put into the bank that's gaining a percentage interest rate as it sits in the bank, or maybe it's your original amount that you loaned from a bank and the percentage interest rate that comes from that. So your initial amount. R is your percentage rate. And a lot of times when we're dealing with percentage rates, we need to divide by 100 in order to get it into a decimal, right? If we're dealing with 30%, we would call it 0.3. That is not the case for this formula. They are already accounting for you not dividing by 100 by putting in the formula a division by 100. So that division by 100 in there means that when you put in for R, if it's 6%, you put in 6 for R, not 0.06, which is great because it eliminates a big issue or a big hiccup that a lot of students tend to have with these types of problems, is that they forget to divide by 100. K stands for compoundings, I guess, but it's the number of compoundings per year. So if you're compounded monthly, the number of compoundings would be 12 because there's 12 months. If you're compounded biannually, your number of compounds would be 2. If you're compounding quarterly, your number of compounds would be 4, that sort of thing. So we'll go through a couple different scenarios like that. If you compound annually, your number would be 1. You see K pops up again in your exponent. It's just because not only are you taking into consideration how many times are you taking this percentage, you're also taking into consideration how many times you're putting this number back into the situation per year. So you're talking about how many times are you taking it per year, but also how many times are you putting it back in per year. And that's what a compounding is that you take a percentage of a number and you add it back in. And so a compounding would be you took the percentage of your original amount and put it back in, and now your original amount is more. If we're talking about letting a certain amount of money in the bank gain value as it sits there. So a compounding would be adding the money back in and doing this calculation that many times per year. N is the number of years. So after 12 years, how much will this be worth, sort of thing. There are you have two different calculators. I only have the TI Nspire. So if you have a TI-84, which most of you have a TI-84, I can't really show it to you. So I'm gonna have to just kind of write out, and all of you who are watching this should be the TI-84 people, because I'm making a separate video for TI Nspire. So TI-84 people, I will be writing out what you should be typing in and then telling you what the final answer is. And so if you get an answer that's different than mine, then you're probably typing it in wrong. But since I can't show you what I'm doing on my screen, you're gonna have to reach out to me and say, hey, what's going on? This isn't working. And I'll get to you as soon as I can. Okay, so you watched, actually no, you are going to be watching right now a video on how to use your calculator to do all of this. Because all of these variables, it's very confusing. And the thing is that your calculator does it all for you, and you're allowed to use your calculator for everything. So why not use your calculator for all of these calculations? So the rest of these notes for today are just going to be, do you understand how to use your calculator for this problem? Because you should always just be using your calculator for this problem. Okay, so go ahead and watch this movie or video that tells you how to do it.